We continue Unit 6, Solving Systems of Equations. At this time, we'll look at equations in the standard form ax plus by plus cz equals d. This is called a linear equation in 3 variables. Use substitution to solve the following systems. Let's start with what we do know. We know that z is 2. Since we know z is 2, we could substitute 2 in for any of the equations above. But the second equation would be so much simpler. Then we would be able to solve for y in this equation. So anywhere I have a z in the second equation, I will substitute 2 into it. So let's set up some columns. 5y plus z equals negative 3 in the first column. Since we know that z is 2, we will substitute 2 in for z and solve for y. Subtract 2 from both sides, and 5y is equal to negative 5. So y is equal to negative 1. So I already have 2 of my answers. Z was 2, y was negative 1. I need to find x. Now that I know y and z, I could substitute both of these back into the first equation. I don't know x, but y is negative 1, and z is 2. Now let's simplify, and we get x minus 3 plus 4 equals 1. Combine like terms, and negative 3 plus 4 becomes 1, so x plus 1 equals 1. Subtract 1 from both sides, and x is equal to 0. Starting with the first equation, when we substitute 0, negative 1, and 2 in for x, y, and z respectively, we need to see if that's equal to 1. And this checks. So far, our answers are good. Check the second equation and see if the left side is equal to the right side. We get negative 5 plus 2 is equal to negative 3. So negative 3 is equal to negative 3, and this checks. Last equation, z equals 2. That one's already done. So the variables x, y, and z are 0, negative 1, and 2. Let's look at another example. In this system of equations, I'm not given one of my variables, so I need to do some extra work. Using substitution, the top equation looks the easiest to solve for x, so I'm going to use that one. When I'm trying to figure out which one to use for substitution, I try to look for one that would be simple to solve for 1x, 1y, or 1z. Now I like to set up columns to keep everything organized, and I will use the first equation, x minus z is equal to negative 1. Solving for x, we would add z to both sides, and x is equal to z minus 1. Since x is equal to z minus 1, I could put this into the second equation right here. There's no x in the third equation, so I couldn't substitute it in there to find the other value. But I can put it into the second equation. So anywhere I have an x in the second equation, I'm going to substitute it with z minus 1. And this will go in parentheses. My hope is that I have another letter that I've solved for. So distributing the 2 throughout the parentheses, we get 2z minus 2 plus z is equal to 7. Combining like terms, 2z plus z is equal to 3z minus 2 is equal to 7. Adding 2 to both sides gives me 3z is equal to 9. Dividing by 3 and z is equal to 3. So now I have a variable for sure, and I can substitute it back into this third equation to get what y is equal to. So substituting 3 into the third equation, anywhere I have a z, I get 2y minus 3 times 3 is equal to negative 11. Simplifying, we get 2y minus 9 equals negative 11. Adding 9 to both sides gives us 2y is equal to negative 2. So y is equal to negative 1. I could solve for x by substituting 3 into z in the first equation, and x is equal to 2. Now we need to check to see if these are true. If x is 2 and y is negative 1 and z is 3, is that true for each of these equations? Let's start with the first equation, and that is true. Let's look at the second equation, and that also is true. We just have one more equation to try. The solution to our system is 2, negative 1, and 3. And this concludes day 2 of systems.